Good afternoon, everybody. Welcome to your 1 o'clock nap station. So George and I, we work in the professional services division of ESRI. And so we work with clients anywhere from designing to just helping them design to implementation of applications or entire enterprise systems. So those applications that we build, they're generally enterprise-focused, workflow-driven type applications. And so today what we're going to do is we're going to walk through how to deliver your projects faster by implementing testing into your development processes. How many people today are already implementing unit testing or automated testing in some form into their development pipelines? Okay, about half of you. That's better than the roadmap session. I was fearful when we saw the hands there. So delivering quality code is obviously important. And to make sure that we're delivering quality code, we have to test it. There's lots of different ways to do that. Obviously, the expensive way is with a person sitting there clicking around. So we want to make it cheap. We want to make it efficient, both for the developers as well as those that are on the test team that we might have. The big misconception I think from a lot of developers is that adding testing into their code is going to slow them down. And just like when we're learning anything, sure, we might take a hit, but long term, adding testing into your development process is actually going to increase your velocity if you're using agile development terms there, right? So you're going to increase what you deliver by making sure that you're testing early in that process. So another big challenge we have is with management and that sort of monetary misconception that adding testing costs me more money than it saves me. People are really expensive, so if you have a live person tester that is doing all of your testing, well, they're expensive. So if we can integrate things in a more cost-effective manner and deliver higher quality code, it's really a win for everybody. As a development community, we of course have to educate those managers and the stakeholders what's going on. And why it's more cost-effective to do that. And if you're on a professional service sort of technical side of things, like we are, warranty work is built into our contracts generally. So, especially if it's like a firm fixed price type contract, if we are iterating over bugs after delivery over and over and over, that affects the bottom line. So that could be very well if you're a consulting company or deliver software in that way. And we can't forget about the users. Users who come and experience a bad application, they're not coming back, and or they're going to let you hear about it. And even if you fix something that was like 2 years ago. They remember that, and they're like, well, but it does this. I'm like, I fixed that bug 2 years ago. Like, why are you still talking about it? They have a really long memory, and especially if your app is monetized, like you could be losing money, losing customers, or not getting new clients, depending on what it is. So here's what George and I really want you to come away from this presentation. We want you to be energized about adding testing into your project life cycles. But adding testing to existing projects can be really hard, even daunting. You don't know where to start. So we just want to sort of talk through where we should be testing. At what level? What level does it make the most sense to do that testing? So we're going to try to demystify this a little bit for you. Some people may have seen this pyramid before. I know it's shown up in some other presentations. And we have these different levels of testing that can happen in your application, and some of them are more applicable maybe on the core side of the house with like the API testing. But functional test is often where people get wrapped around their head at what testing has to be. This is this end-to-end testing that has to happen. You know, the browser's up, the user interface is fully loaded, and you're listening for events, and you know, God help you if like they change something in the underlying framework they're using, and all the DOM nodes change, and you know, you're out of luck. And so it's really costly to, first of all, make those kinds of tests. Then it's even more costly to maintain them, because little things can change, especially if you're trying to keep up with things. Now down at the other end, we get into the really cost-effective type of testing, unit testing. So we're going to be testing really small pieces of code, and we're going to make sure that we're testing our code in that little piece. So we, as a result of that, can iterate really fast, and we can make sure that the code that we're delivering is quality as a result of that. And those tests aren't going to be dependent on the DOM and things changing, and so they'll be really resilient even as we go through upgrade cycles of the API, of the libraries that we're using. And all those are really good things. Oh, and so what happens when we get into these nightmare situations? That shows up really poorly on there, doesn't it?
Yep.
So on this slide, we have an upside down pyramid, and things are all cattywampus on here. Whenever we get into this sort of nightmare situation where our initial tests aren't end-to-end, we get a large number of bugs, and we wrote a single test that was far too large, encompassed far too many things, and everybody is just ignoring the fact that it's failing and has failed for a long time. You know, we want to fix that. We want to make it so easy to fix that, you know, somebody doesn't feel pressure to pick it up, you know, out of the development stack. So I'm going to hand it over to George, and George is going to talk to us a little bit about how we look about writing our code and writing our tests.
All right, thanks, Randy. So throughout this talk, really we're going to be driving home a point that writing good tests isn't really about the technology. It's not about which framework you pick. It's not about the semantics you're using. It's about a process in which we work, and as the technologies change, you know, you can continue to adapt, use whatever you want, and still succeed. So when most people first start experimenting with unit testing, and myself included here, you're kind of drawn to this general workflow as a developer, where you write code, you write a test, the test passes because it's fit to your code, you write more code, the test breaks, then you refactor your test. And what ends up happening there is that you write a test that's built around your code, so it's always going to pass. You know, you look at the methods that are getting called, you verify that they're getting called, and it passes. What we really want to do is work with test-driven development. In this case, we actually start with writing a test first, built on a requirement. And that helps get you really user-focused. You write your test. If your test is going to fail because you have no code to support it yet, but it's going to be built around that user story. Then we write code until the test passes. Once the test passes, then we check to make sure we're actually meeting the functional requirement, and we can refactor the test if it's still not right. We refactor the test, we write code until the test passes again, and you just cycle over and over again like that until you have a fully working app. And by the time you're done writing your app, it has a full test suite, and everything should work great. It can be hard to wrap your head about that, but the key is to focus on encapsulation and writing them at the very beginning. If you separate each bit of functionality into individually smaller functions, it's going to really help you write those tests easily. We tend to get in a habit when we're writing code to put everything in giant function blocks. We have our on-click handlers. People do a lot of inline event handlers, things like that. You want to split those out. If you have trouble thinking about that, if you have trouble getting started, getting that test, oh, I just want to put everything on function, one exercise that helps me is to go through and look at my requirements, look at everything I have to do, and build out a skeleton class. So what I do there is I build all my functions, every function name, in clear English with what I want to happen. And I'm not filling this in with any logic. I'm just putting in what I want to happen. So let's take a look at something like that. I have a test application here. It's pretty straightforward. It's just got a map as a little toolbar. We have a show transportation button. We have some asset layers that can come up on the map. There's a travel ring tool that pops up a dialog when I click on the map here. And we have a clear graphics button. So it's a pretty straightforward app. You can see a lot of that stuff going in together. We're going to take a look at the show transportation layer and how we might design that. So this is where I might start when I'm building a function, right? There's nothing actually happening here, but I'm walking through and filling out that toolbar with the requirements that I know. Let me make that a little bigger for you. All right. So I go through here, and I know that I want the toolbar to be draggable. So I just say make toolbar draggable. I know that when you click a toggle transportation button, I want to toggle transportation. And I walk through step by step in plain English. I don't fill in any of the functions to actually work. But what I have here now is a clear skeleton that I can go through and start writing unit tests for each one of these. So it really helps you lay out, and it makes it so that you can avoid putting giant functions in when you already have these lined out. All right. So another way to make sure that you're writing these easily, that you're not struggling with the API, is to avoid testing other people's code. And this is especially important when you're working on applications that run different frameworks, that rely heavily on external libraries. Something like the ArcGIS JavaScript API. You guys might be using that. So we don't want to check in our test to see that the map's at the right zoom level or if a layer has rendered. That's hard. And the JavaScript API team already does that. That's their job. That's not our job at writing an app with it. We want to test to make sure that function was called correctly. So we use this method known as spies and fakes to do that, where we fake that the method is being called. There are a number of libraries that do this. I personally like to use Synon.js, and I'll show an example using that in a little bit. But really the idea here is these methods allow you to call the function that you're testing, which may call setExtent, it may call goTo, it may call hide or show, any number of things, but it's not actually calling that method. Instead, it just watches to see that it got called and tells you what arguments got called. So let's take a look here, back in that test code. So in here, we have a toolbar component. If I go down, I can see some tests. I have a clear graphics and an info window here. And I'm creating spies. This is, again, using a very specific framework, but you can go online, you can pick whatever you want, and just roll with it. So I test the toolbar, the graphics, I just make sure they've called. I make sure remove all has been called, I make sure that this pop-up has been called, and then I run my tests. We're using a number of components in this application, so I'll go over with what they are. We're using Grunt to actually run our tests, and we're using Karma to pull up browser emulation and to make sure things are actually happening. This is a configuration file for Karma, and if we walk through it, we can see what's happening. First, we have our framework section that specifies we're using Jasmine, which is a type of syntax for running tests, an assertion language. That's what's going to define how we structure our tests and how we write them. And then we're using a Dojo framework for Karma, and that allows us to test the JavaScript API more easily. It allows us to bring in all of those AMD modules that sometimes can be difficult to load without actually doing any work ourselves. I tell it which files I want to test and include in the runner. I have some reporters here. Dots just displays some regular information, and then JUnit is going to put out a simple XML file that we can run in continuous integration down the line. I say what port to run on. Again, some logging information. And I say I'm going to use Chrome headless. And in here, you can use a number of different applications. You can start Firefox. You can start Chrome. Chrome headless is really good for automated application testing because that runs outside of the browser. It runs from your command line. So if you're running this in Node, if you're using Grunt, anything like that, Chrome headless can run on any system, and it's not going to have to bring up a new browser. In Grunt, which is our automated tasking system, we have another plugin for Karma, and that runs through and lets us specify we're using that config and to run in our application. So then when it comes time to actually run the code, I can just type in my command line from the folder, say grunt test, and it'll go through and start running those tests. So a lot of that stuff is very closely integrated. It's based on the technology. When you want to actually start writing it on your own, if you can't come up with them, which ones to use, I would recommend using Karma and Syn.js, but you don't have to use that. There's a lot of different languages. A lot of them are trendy at different times. Most of them are very similar, though. There's a lot of examples online, and they're very modular. So a lot of these you can plug in different things, you can pull out, you can use different frameworks, etc. You can even use any of those trendy frameworks that you want to use, like React or Angular. All of those have test frameworks built in with them, generally well-established practices. A lot of people get caught up with, now we're loading another framework, how do I test these JavaScript API functions? How do I bring in the JavaScript API and still run my tests? It's just not going to work. Well, you can use any framework you want here. There's a tool we have called the ESRI Loader. And what that does is it abstracts a number of these frameworks out from the JavaScript API. So if you're using React, if you're using Angular, if you're using Ember, it's going to take out that whole AMD loader. So you can even mock that in your tests. So then you're not even bringing in a map object or a view object. You're just rolling with things. So I know a lot of you guys probably work on existing projects, right? This is great to hear for a new project. You can roll through with some of those command lines. You can start up. You can copy our project. But how do you do it for a legacy app? Supporting legacy apps is a fact of life. You're just going to have to do it. But that doesn't mean you have to abandon hope for using good practices and writing good tests. We've successfully implemented unit testing on top of existing behemoth applications lots of times, and it doesn't have to be the nightmare it may seem like. The key here is to really start small and to make sure you're focusing on encapsulating your code. So as developers, we're really good at writing code that's really hard to test. And we've probably already done that in our existing apps. We probably have giant function blocks. We probably have nested blocks of spaghetti. There have been bugs that have come and gone. Things are looking pretty tough and looking really hard to test. So a lot of people will go in. They'll have great plans of starting testing on this app. They can't find a place to start. They can't find a new piece. That's fine. You don't have to go in with 100% code coverage, right? Start small. Look at what's there, maybe only work on new bugs. Make a rule, every time you find a bug, write a test for that bug. Every time you write a new feature, write a test for that feature. Even if it's not in your old code, you'll find your quality increasing, you'll find your tests becoming better. When you do find time to add testing, pick a little piece. You don't have to do a whole function, and take that out of the function. I'm going to show an example now of what that might look like. So this application that we've been running, wrong thing. There we go. Okay, so this application that we've been running, it's not just built around a testing example. It was built to demo a Dojo build. And some of the things aren't exactly written in a manner consistent with how we would like them to be. So let's look at this travel ring dialog here. This has a pretty messy function. Get ring. If we scroll down here, we can see some familiar patterns. We see a geoprocessing tool, it executes, and then we have right in line here a number of results. It's a lot of stuff going on here, and that can be pretty hard to test. So what I'm going to do, instead of trying to write a test that says, okay, I want to test this whole getRing function, I'm going to take some of this code out and start to refactor it, right? So a good place to look is anywhere you have if and else blocks. Those are great places to start looking for tests. Anywhere you have code, if you have event handlers, those are great places to look for adding tests. I'm going to look right here where I have this loop, and I'm setting symbology on a graphic. So to start, I'm just going to copy out all of this code here in the middle of this for loop and move it to another function. So let's call that set symbol, and we'll put it on our feature. So I go there, then I'm going to go down, add it as a new feature. So set symbol with a feature. Copy that, and we can see now we have some things here that might be harder to test, might be hard to encapsulate away. Maybe the new simple fill symbol, I don't want to make sure that's being created. I don't want to worry about testing that. So let's just take that out and make it a parameter. Fill symbol. And I can add it up here and add it as a parameter. Very straightforward, right? So we have a test here. We're only testing 2 lines of code. And what we're actually going to test is that set was called on the feature, and that add was called on the graphics. All right. So I'm going to hand it over to Randy now, who's going to talk about some other tools you can use to help integrate this testing into your workflow and to really work on improving your code quality overall.
So everybody's confident they can go take what George has done and start implementing it today, right? It can be intimidating. So let's step back and let's even start with just a little easier entry point. Let's get some confidence, then let's go for the testing, right? So when we're talking about JavaScript code quality, a linter is an excellent way to begin the process of making sure that your code is sort of up to snuff, right? So in the past, maybe you've used JS hint or JS lint as options there. Those are great things to be doing. The popular one now is ESLint because it seems to really have the best forward-thinking, flexible configuration to let us move forward into ES up to like 2017 TypeScript type support. So ESLint is a great option for you to do that. It is the most downloaded, or not it's in like the top 100 most downloaded packages from NPM. So I think that tells you how much it's really in use these days. So it's really flexible on how you set rules and ignore rules. If you're familiar with JS hint or lint, like it's similar in the way that you do that. So let's just sort of let's look at that. Let's look at what an ESLint configuration would be. I don't know if anybody. Well, I saw a few nods of the head about other ones. Installing ESLint is really easy. You can run it command line. It's integrated into tons of IDEs already, or there's a plugin for it. Sublime, VS Code has it in it, and so you can do it really easily and run it command line. That's sort of what we're showing here with the on the getting started page here from ESLint. And then, so what does the config file actually look like? I really liked looking at ESLint and switching over from JS hint. Just the initial setup was so much easier for me. And you can add it in, and then just like George was talking about with picking off a bug or adding things little by little, you can do the same thing here. George and I switched over last night from JS hint to ESLint, and we were a little horrified to find a few things that it came up with. I think we started with something like 200 errors, and so of course we fixed them all, right? No, we added these 3 lines to ESLint, and now it passes like a dream. But what we need to do is, in future development, we need to go back and we need to start picking these things off. Maybe I'm not so worried about mixed spaces and tabs in my code, but maybe I really don't like the fact that unused variables are lingering around in places. So these are things that I can control. Ideally, George and I would get rid of these 3 lines and things would all pass, but it was late. So that's what it looks like itself. Really simple to set up. Your IDE will pick up this ESLint RC file and just know that it should be using it. Now, George mentioned that we're using Grunt for a number of things. So as a developer sitting on my workspace, how do I know that things fail, that things aren't passing my code quality checks with my linter, that aren't passing my karma tests or whatever test runner you're using? So we're going to use Grunt to support that as a developer. So we have a build sample application that George mentioned that we've been using for a couple of years now. And so we have Grunt integrated in this. Grunt is just a task runner. You can, if you're old school, it's like Ant or something. If you're hipper than we are, you're using Gulp. But so what I'm going to do in this case is I'm going to run a Grunt serve. We have serve integrated into the application, and what it does is it launches the application. We can see it running. It's good. So over here we have our Grunt. We have our Grunt running, and we can see it. So I'm going to go into the code here. And as you can see down here, we have the serve integrated with a watch. So the first thing it does is it essentially starts like a little HTTP server. And it's running and it's launching. And then we paired it with this watch task. So the watch task is looking at our JavaScript code, the files on disk, and watching for them to change. So we'll come in here. This is our site manager. This is sort of like the brains of the application. And we're just going to break it. And so I made a change, and I didn't see anything. But things should totally not be working, right? So let's go look at our Grunt file. Oh, well, so in the watch right now, we're watching these files, but we're not doing anything. So let's add our testing to it. So we'll add our test task here. Now, a test task that we've defined down here in Grunt does 2 things. It runs ESLint, and it runs karma. And if you were distracted while I was talking, you could see that this big red error came up. and it was really unhappy. You know, I can see exactly what file it happened in. I can tell where it is. It's showing me, you know, that the toolbar line is like, what? I wasn't expecting to see this. So we'll just go ahead and fix it real quick. And while we wait for this to run in just a couple seconds, Karma takes a couple more. But you can see we already passed the ESLint checks. And Karma's done now as well. Just took a few more seconds. And so now, as we're developing, we're getting real-time feedback about what is working and what's not working in a way that we certainly couldn't have like 5 years ago. So this will help you increase your code quality and probably even break you of some bad coding habits that you might have. But so ESLint, you know, remember, take it a step at a time. You know, maybe you add a few of these not so desirable exceptions like we have in our project, and then, you know, progressively work through them. Add them to your backlog if you're on a large enough project that you're tracking a backlog. But it can be great for your small projects too. Help you become a better developer and help you become sure of the code quality that you're delivering. I didn't choose the right mode there. All right. So we talked about grunt and gulp and integrating things continuously on the developer side. But what about when developers check in code? Developers check in code. Sometimes they can circumvent the process, you know, not really have run their unit test properly. Maybe they upgraded their environment and they forgot to add the ESLint plugin back in, and you know, it's just not right. Maybe they, even worse, maybe they edited a file like on GitHub, being sneaky. They thought, oh, all I have to do is like add this semicolon and it'll all work and it'll be great. So, so what we want to do is we want to start to use a piece of software called Continuous Integration Server to be testing all the code that's coming from our source control and use that. So 3 examples here, Jenkins, Hudson, Travis CI. Those are all really popular ones. There's even more out there. You know, TFS, if you're a Microsoft type shop, has continuous integration built into it. Circle CI, there's others out there. So what we want to do in doing this is we're going to look at it from a testing perspective right now. So we'll bring up Jenkins here, and this is what it looks like. It's really easy to integrate in. George mentioned earlier that in the grunt task we have it outputting JUnit tests, that XML file that he mentioned. Well, because of that, we have our Jenkins job here that runs. I have this one set up to run manually right now, but you know, you can have it pull your CI. So every time it finds a change, it'll run automatically. You can have it run daily, nightly. And that XML file gets picked up. So we can come in here and we can look at the test trends. Right now, things have been really successful. But we can dig in. We can see, OK, we're only testing Chrome here. That's the only browser we have going on. We have the toolbar component. We come down here and we can get into the individual tests. And see what the result was from those. So it can be really easy for us to find and identify quickly what tests are passing and what tests are failing, even trace back more quickly who to blame, because we all like passing that around, right? It's not my test that failed. It's George's. So if you want to learn more about using continuous integration into your processes, George and I are giving a talk here. I think it's in this room at 5:30. So you can hear more about implementing a full DevOps pipeline from coding all the way to production deployment of your application. And testing in that pipeline is a key component for success there. So source control. Is anybody surprised to hear about source control and a testing talk? So the reason that I think that this is a really important point to bring up and talk about testing is if your source control is not set up right, if you're not following good practices in managing your source control and managing your project, you're not going to be able to test successfully. You're going to end up with bad code in your repository, and you're never going to have confidence that you have, at the end of, say, a sprint, that you have a releasable piece of code. So this is one style that we've been using on some projects, and then I'll sort of go over a little modification that I think works a little bit better for smaller projects or smaller teams. So we have two branches here. Is anybody using anything besides Git right now as their source control? All right, Subversion, Mercurial, yeah, okay. So the concepts are the same, really, regardless of which one it is. You have, if we're going back to Subversion, we have like the trunk branch that we usually call it. Today we usually call it master in the Git world. And we make a release candidate. The release candidate is actually where we do most of our work. And I have seen some people sort of flip these because by default, especially if you're using something like GitHub, like by default, the master branch is always active. So they get frustrated going in and trying to like search for something in the repository or something like that. So they swap the two. But the important thing is that we have one branch that is our stable code, our released code, and especially if we're a project where people are coming and getting things from us, like a library, like we want to make sure that they have a clear understanding of what code is good and ready to go. So we start committing to our release candidate branch, and we need to start making some features, right? So every time we make a feature or work on a feature, or even a bug, you can do this, we create branches. And we start doing our work in those branches. You know, it's okay if you got just a little thing to submit it right back to the release branch, but certainly the best practice is to use these feature branches. And when a feature's done, we'll merge it back into the release candidate. If you're using software like GitHub or GitLab is one that I've used a lot on projects lately. Bitbucket does the same. You can submit merge requests back in, and that's a really good way to make sure that you're having somebody do a little bit of a code review. So we're right back to looking at that code quality, doing a code review during that merge request time, and making sure that things are going back in properly. And in all of those tools, make it really easy to prune and clean up these feature branches, because I definitely, every time I present it, I hear somebody say, but that's so many branches in the repository. Well, you clean them up as you go, and it's fine. And so we finally we're ready to release, and we merge everything into that release branch, that stable, that master. Okay, and so we know people coming to us, they know exactly what it is. If we're doing a deployment somewhere, we know exactly what number, what code revision was deployed at that time. And you know, and so features can continually pull from that release candidate branch, making sure that they're up to date, which also makes merging back into the release candidate easier. Right? So you can see here, if we were doing all this work in the release branch, like it would be really easy to commit code that maybe didn't have the right test coverage. Maybe you didn't realize it was failing a test, and now you have code that's tainted that you have to roll back or fix or figure out what you're going to do with, like in your main line of development, right? So we want to make sure that the features that we're developing are fully complete, have those test cases before we get them merged back into our main branch of code. So let's modify this just a little bit, and we'll sort of go through this. I've completely gotten rid of that other branch, the release branch, what we were calling master in that case. I've labeled it master here. So on a smaller project, I find, especially maybe it's internal, maybe you have a team of 2, right? These concepts, they still apply, and they're still really good best practices for you, but you don't necessarily need the overhead. of merging then to a whole nother branch and managing that in another way. And maybe you're not managing multiple releases concurrently. George and I often do that on the really large projects that we're on. We'll be running like one set of code will be running through the acceptance testing, but we're still developing on the next release of the code as well. And so managing those in parallels really requires you to manage branches in this way. So in this case, we've simplified things. We've just gotten rid of that whole extra branch. And but we're still using the best practices of branching for features, committing everything there, making sure that we have the right test, the right passage of all that before we're merging it back into the master. We're not going to talk about it in this afternoon just because it's a little bit of advanced and we want the build session that we're doing later to really be for sort of any level of person. But if you were doing this, you could even have your continuous integration query and run like the linting test or the unit test against like every single branch that gets created. So then you're assured that not only is the developer doing their job locally, but before it gets merged in, that the code that is coming in, you have some assurance that it's right, that it's not going to break everything else. So we're getting close to the end here, and there's some great talks that are coming up later. George is giving a talk on. I'm not doing that talk with him, but George is doing a talk right after this over across the way, and it's not in this room either, George, is it?
No.
So. Take this slide with a grain of salt. So, but it is, the time is right.
Got that.
Yeah. So George is doing a talk with Gavin, and they're going to talk about Web App Builder and developing custom widgets and tools in that. And then, which will be a great talk, especially if you're in Web App Builder or you're even doing like custom JavaScript API apps and interested in how you can take that customization and apply it into a Web App Builder scenario. That would be a great talk for you. And then we're going to piggyback and build on sort of what George is doing in that talk in our final talk of today, which is actually in this room, building for production. In that talk, what we're going to do is we're going to sort of go through best practices for your application from how you should set up the server, how you should take your app from your development code, running through a continuous integration pipeline all the way to deployment into production. So that one will be really good, I think. And we're going to cover both custom applications and making sure that they're production ready, as well as Web App Builder applications, building on the techniques that George and Gavin present at 2:30. So some of the resources that we use today, we have that enterprise build sample application where you can find the project that we're using, the tests that George was working through and modifying, as well as the Web App Builder application that shows testing as well. We have the ESRI Loader, the lint, and the source control as well. And a great talk on unit testing there at that YouTube link. That's if you haven't seen that or are wanting to continue to build your knowledge on unit testing, that's a fantastic one. We really do look at the feedback every year. We love the feedback. We want to know what works for you in this talk, what doesn't work for you in this talk, what you want to hear about. If you don't think it's needed anymore, I hope nobody thinks that they don't need testing anymore. But we really do want to know what you think about this. So please fill out the survey there. We do have some mics up here at front. We have some time here to answer some questions, and we will certainly be sticking around here for a little while afterwards as well. If you we'll be here, like we said, at 5:30 here tonight for the party. And my Twitter handle has a S on the end of it, I just recognized. So you can always tweet us, find us at the party too. We'll be here. And we have some microphones up here. If anybody has any questions, we'll try to answer those.
And just real quick, to correct that earlier slide, the Web App Builder presentation is going to be at Primrose C and D. So if you guys are interested in checking that out, that's over there. All right. Any questions? Yes. Do you want a microphone or?
I think I can speak pretty loud.
Okay.
So with test-driven development, if everything starts with the requirements for a story, do you find that a team doing it for the first time has trouble coming up with bigger requirements for stories?
Yeah, I think sometimes and the question was, do teams just getting started with test-driven development have trouble coming up with requirements for your stories? And I think a lot of times people getting started can wrap their heads around a little too much with the formality of making requirements and trying to format them in a certain way. That's not really what I'm talking about when I say requirements. I'm not talking about a specific agile framework or some type of project management. It really is, at the base level, what do you want your app to do? And a good way to start doing that is to think of yourself as a user and to say, I'm a user, what am I going to do? And your requirement there, like say I wanted to find my house on a map. Your requirement could be, as a user, I want to find my house. And then you can work through and evolve that. So I want to click a button and have that find my house. I want to click a button and have it zoom into my house on the map. And now you have a requirement. So it really is just putting yourself in the user's shoes, imagining what they're going to want to do, what you would want to do as a user, and not what you would want to do as a developer or a project manager or something like that. Does that help?
Yeah.
Awesome.
Well, and just to add on that, I think it is absolutely fair to say that it's difficult to find people who write good requirements. So it's just as much a great skill to have somebody who can help somebody through getting to the requirements that they want. So yes, that can be difficult, but I think just with practice, that definitely comes along. If you're in front.
Yeah, at the beginning you talked about the difficulty of justifying testing, right? Mm-hmm. Managers and that, and I was in a conversation, and this is a developer-developer conversation, and navigating through this space to get something implemented was the discussion or the pushing for we need to do a lot more negative testing of all the functions. We need to test both the desired positive state and the negative state to root out bugs. And they said back to me that in contrast to the agile movement that says the moment you have demonstrable benefit to the business, that's our obligation to move it to production as soon as possible. Rather than holding things back until they're perfect, the minute you have demonstrable benefit, get it out to prod. When it fails, we'll fix it quickly in prod. And I listened to that. It was almost a company attitude, and I realized there was a collision of ideologies. And I was like, yeah, I've heard that before in modern agile development. And I was going, wow. And I was going, we're like, different religions. I was going, no, we're the same people. We're modern developers. And
Well, I mean, the framework wars are over if you're on that train still, right? So, and same thing with testing and all that. Like, I think with Agile, that is a strong misconception that we have to move so fast that we don't have time to test. No, the moment that you know that code is ready to go to production is when you've written all the tests, it passes all the tests, and then, you're going to have some QA cycle there as well. But so what that might look like within your organization is going to vary, right? But the way that you get it to production, and you're not going to guarantee this code is bug free, right? But the only way that you can be confident that what you're pushing all the way to production has any semblance of being correct is to test. And the cheapest way to do that is that unit testing.
Yeah, and I'd like to add to that. It's not just, I think a lot of that framework is, we write the code and then we write the tests. And just because you're doing negative tests where you want to test failures and things, that still can be part of the design phase, right? So when you start writing your application, you should be thinking about what happens when things don't work. You should be thinking about, what inputs shouldn't work, what inputs should fail. And part of thinking about that is writing those negative tests. So if you write a function with invalid input to start, then you know that you're handling that invalid input when you push it out to production. And then when your feature is done, when the functionality is complete, you already have the tests and that argument is moot. You don't have to convince a manager to go back and write more tests because the tests were already there and they were already part of the planning phase.
I think we can talk about that. You can bake it in if you're writing a spec for a contractor to write ESRI code, that we would require you to do that. But I think it's a misinterpretation of the concept of it has any value at all ahead of the product. So I know the senior manager knows the cost of fixing it in prod. They believe that you're going to lose so much money because the cost of fixing it in prod, your picture of unhappy people, you cannot quantify that, right? There is no value in moving code that's passed the happy path test. Yeah, it worked once and it worked great, but now they discover some new data and they go, well, we never tested that because it wasn't.
Definitely.
But I was startled about that. But that is an interesting argument saying you're misinterpreting what they meant by the agile movement.
Yep.
No one ever meant that you should move code that was not thoroughly tested. That sounds like a
Yeah.
response. That's misunderstanding what they meant.
Yeah.
Value is.
Yeah.
Cool. And we can talk more after the.
Yeah, I think there was, yeah.
In the presentation, you mentioned that there's lots of JavaScript unit testing frameworks out there. I've started trying to play with them, and I've noticed that it's hard to find ones that have good tutorials or instructions for integrating with large libraries like Dojo and ArcGIS JavaScript API. Are there any particular ones that have good documentation or tutorials for integrating with the ESRI SDKs?
We have a few. So the question was, are there any good testing frameworks that have tutorials for integrating with the ESRI JavaScript API? And we have a few examples out on using Karma with the JavaScript API. If you look at our sample build, you can see a few steps there. There's a Dojo plugin with that works. I think, again, going back to that not testing the ESRI API, so sometimes you are going to have to load Dojo, but you don't want to get in a situation where you're calling a lot of Dojo functions or calling a lot of ESRI functions from your test itself.
Yeah, and I don't think that there's a session doing it this year, but last year, I think you should be able to find online the session that used Intern as an integration point into testing with the JavaScript API. Mm-hmm. Yes?
So my question is, how do you draw the line between the unit testing and the UI testing, especially in the case of JavaScript? So if we go back to one of the high-level languages like .NET or Java, you can do the unit test is really purely defined. Okay, this is where my business logic is going on. I'm testing. I don't need the UI to be open. So I'm expecting this. I test against this. But with the JavaScript, 95% cases, the logic is correlated with the UI. So let's say talk about like our ESRI map. You want to test like I have this graphics and I want to load the graphics to the map. So the unit test might be that my graphics loaded to the map properly or not. But that's where how do you draw that line? That is it a UI test or is it a unit test?
So the actual the question was, how do you test the UI? If you're writing a unit test, is it really a unit test? If you're adding graphics to the map and you're testing if they've been added to the map, right?
Yeah, is it really a unit test or is it really a UI test?
Well, that would be a UI test, and that would not be a unit test. And because what you really want to do is you don't want to test to see that the graphics were added to the map correctly. What we're going to end up testing is that we called the correct function to add the graphics to the map. And that way, again, you don't have to deal with waiting for the rendering of the graphics. You don't have to deal with finding the graphic elements on the map. You don't have to deal with which renderer the feature layer is using. If it's using Canvas, if it's using WebGL, you would have to test those differently. So we're not testing the results of the JavaScript API code. we're testing what our code is doing, and that's doing it correctly. Does that help? I know it can be a tough thing to wrap your head around. It's again, those SPI frameworks, definitely look at Syn.js or something like it. We really do not want to get involved in looking at the properties of the map or properties of a layer and making sure they're correct, but just testing to see that we did everything we were supposed to do as developers.
Yeah, you sort of asked generally, like, where's the line? The line is somebody else's code, if at all possible, right? So test the logic that you were doing to build up the graphics and the call that you made to the making a fake for like the graphics layer, right? That you're going to call add graphics on, and make sure that that's called. But that's where you need to end, and that's where Renee and Jan and all those guys, all of their testing takes over, right?
My question was basically beyond that. So let's say you're testing my code. Even with the JavaScript code, so much UI is involved that you open the browser first and then you do the testing, which means the UI is involved. So how do you really draw the line? What is your unit test and what should be the unit test and what should be the UI test?
I mean, so generally I don't even open up the browser when I'm doing when I start writing my tests. I might do it as I start gathering requirements and things like that. But really, as I do my development workflows day to day, I'm running tests from the command line, I'm changing code, I'm running tests again. And then, yeah, I go and I verify that things are working correctly. I might change my tests as a result. But, you can separate them from unit tests. We have done it successfully. And you have to draw that line yourself, right? You have to decide what's going to be low effort and what's going to be high effort. And if things are going to be high effort, chances are that the code itself doesn't have a lot of separation. So that's where that line comes in. It's, pull out your functions that, if you're having trouble with, pull out your code that doesn't deal with the UI and test that and work and focus the base of your testing on that piece.
Discussion. Your question brings with me about how when you test classically, years ago you were taught that there was unit testing, and it doesn't jive with your definition. Unit testing was back-end testing. UI testing was like end-user testing. But I think there's a shift going on, is that what unit testing there is to find a code you have written. It's not whether it's in the GUI or in the back-end. That separation that I was doing, back-end, front-end, user testing is the end-user testing. That's now called functional testing. And it may or may not be about the UI or not. So really the key is, that's what I'm thinking of you, is that you unit test code that you've written.
Yeah.
And not APIs or whether.
Yeah, well, and that's a big driver as a result of the change of the functionality that the browsers can support over the last decade, for sure.
Yeah,
The browsers are so much more powerful that we don't have to do as much on the server as we used to.
Right, so the unit test you made classically, and doing unit testing is something in the past we thought was a user interface, but you wrote the code, so it has to be unit tested, even though it's very, very close.
Yeah, your business logic may very well be in JavaScript on the front end, not on the back end in Java or .NET or Python, like it might have been before. Yes.
I'm also worried about this JavaScript testing, and I find that we can test 80 ahead of 10% of our code. That's what we see. And I think the problem is that, say, in JavaScript API, ESRI shows examples how to finish other people. And these examples are made short to make a long. All these examples are not prepared for unit testing because everything is. But when people write real live applications, we find similar example, copy-paste code, then modify a lot of things and end up with everything is mixed situation where you can business logic and UI logic, promise catch.
Yeah, and so the question was, not much of a question, but more of a point that in the real world, code is sloppy, and there's a lot of copy and pasting, and there's a lot more functionality than we have in our demos, and which is true. And that's what I was hoping to show when I pulled up that sloppier function and I started pulling things out from it. That code is inherently hard to test when you develop like that, when you're copying and pasting things. And I understand that in the real world that happens. Sometimes you're just rushing to get something out the door. Things are hectic. You're just trying to get it done. And I understand that that happens. But you don't have to test everything at once. You can pull things out and try to do it better a little bit at a time. When you're starting to make something new, try not to copy and paste everything from the samples. Or if you do, I know that's, easier said than done, but it really is the point we're trying to make here, that if you want higher quality code, you have to write higher quality code. You have to work on encapsulating things and really not just putting everything in a single index.html file. Does that kind of clarify things a little bit, or do you still feel really hesitant?
I feel that I can bet $100 for that it happens 80% of situations for ESRI API development.
Yeah, I mean, based on a lot of the real world code I've seen, a lot of them are like that, but I would argue that that's a really good way to get a lot of bugs and to make hard to fix bugs.
Yeah, I mean, we've been working with a JavaScript API for a long time. Like, I've been working with it since the 1.0. And I would say the quality of code that I'm seeing from users over the last 5 years has definitely increased a lot. I don't see as much single page spaghetti code applications as I used to. I mean, I've seen 14,000 lines of JavaScript code in a single one before, and debugging those is extremely hard. So as a community, there's been a lot of improvement, but I think we can continue on that path and get even further.
Any other questions? All right, thanks guys.
Thank you.